Hello everyone. So today I'll explain a very important topic in machine learning which is called feature scaling, and this explain the difference between standardization and normalization. So this is Dr. Anirban Das Gupta and let's get started. So imagine you are predicting house prices and you use two features. One is say area, something like 2000 square feet, and the number of rooms, say 3. So now the question is, don't you think one of these features will dominate the model? So I keep this as a question, that which one will dominate the model. Now if you see that if I try to bring these two features into two axes, say x and y axis, and maybe the third axis z axis is the house price prediction, then the range of these feature values are extremely different and it will be very difficult to put them on the same scale. So the core idea is that different scales typically bias the model, and hence we need something called feature scaling. What is feature scaling? So feature scaling is a process of bridging all these features to a similar range so that no feature typically dominates due to its magnitude. So there are two methods of feature scaling. One is standardization and the second is normalization. So let us try to understand what are these. So what is standardization? It is also called z-score scaling. So for examples, let's say x are the feature values, and so this is the single feature and I have several values, some n number of values, and I call this feature vector say x, and mu is the mean of those values and sigma being the standard deviation of these values. So the standardized features z are obtained as x minus mu by sigma, which means I find the mean feature and then I subtract all the feature values by the mean, and then the result I divide by sigma. So by subtracting the mean, what I get essentially is a zero mean feature, and by dividing by sigma, I get standard deviation of unity of the resultant standardized feature values. Now these values can range from minus infinity to plus infinity. So which means standardization typically doesn't limit the values. It just recenters and rescales. So when to use standardization? Now there are algorithms like certain algorithms which assume Gaussian distribution of the features. So in such cases, standardization is used for feature scaling. Also gradient based models like linear regression, logistic regression, neural networks, they prefer standardization. Now coming to normalization. So what is normalization? So it is also known as min-max scaling. Now what normalization does is basically, so suppose if you have your feature values x and the minimum and maximum values of these features are say x min and x max, then the normalized value x prime can be obtained using this formula, where I first subtract the minimum value from the feature value and divide it by the range of the feature values. What is the range of the feature values? That is maximum value of the feature minus the minimum value of the feature. Now in this manner what I can get is that, so what is the maximum value x can get? That is x max. So when assumes x max, then if x is equals to x max, then value of x prime will be 1. That is the highest value of the normalized feature. And if x assumes a value x min, which is the minimum value, then the value of x prime will be 0. In other words, this x prime scales my features in the range 0 to 1, and it preserves the shape of the distribution, unlike standardization. So whatever be your initial feature distribution, your normalized distribution will have the same distribution of the original features. So when to use normalization? So wherever you use distance based metrics like k nearest neighbors or k means clustering, or even in image data, suppose you are using a convolutional neural network, so your image data, that is pixel scaling, is required, which is a normalization step. Let's see a numerical example. So if we have these as my feature values, say 5, 10, 20, 30, and so on. So if we do standardization, so first is we find the mean, and the mean will be 30. So here we see that the mean values are projected to 0, whereas if you see, the standard deviation of this is unity or 1. Now this is not restricting the values to any range, but it is making sure that the mean is 0 and the standard deviation is unity. What about normalization? So normalized features will be x minus x mean. X mean is the minimum value of x, which is 5, divided by x max minus x mean, that is the range. So x max is 55, x mean is 5. So this range will be 50. Now once I divide this, I get this normalized value, which is in the range 0 to 1. So graphically or pictorially you can see, so if this is the original data, normalization will compress the data in a unit square, or whatever is the dimension of the data. Here, since it's a 2D data, so we have a 2D normalized data, which is a unit square. Whereas standardization, what it does, it doesn't guarantee any limit, but it will center it to 0, and it will have a unit standard deviation.